Okay, welcome to the video for 2-8 solving inequalities in one variable. So one variable just means we have one letter in there, and now we're not dealing with equal signs, we're dealing with inequality signs. So I will be able to solve polynomial and rational inequalities. Okay, so back in section 2.3, we graphed polynomials like this. We used what we knew about its multiplicity and its positive and negative and the end behavior, and then we would create a graph like this. But for inequalities, we just care about the interval on which the function is above, or when you plug in x's and you have positive y values, or below, so negative y values, the x-axis. Right, so on the interval, we're trying to figure out, first we're going to look at this graphically, so it'll make more sense when we don't have a graph. Right, so for inequalities, we really just need to see, well, where is the graph above or below the x-axis? Where are the y's positive or where are the y's negatives? Solve the following graphically using the graph on the right. Find the values of x so that, and we're going to do each of these individually. So we want where the function is greater than 0. So where is it greater than 0? Well, it's greater than 0 here and here. So this is an interval because this isn't just one number. We're going from negative infinity and we're coming to negative 3, not including negative 3, and then we have all this space in between, and then again at positive 5 to infinity. Okay, so now we want to see where it's greater than or equal to. Okay, so it's still the same spots as far as highlighting, except now we're also going to include these points here. And I want you to notice greater than or equal to 0, well, it's equal to 0 here, it's equal to 0 here, and it's equal to 0 here. So we have negative infinity to negative 3, but this time we're including negative 3, union, and since it's equal to 0 here, we need to include 2. It's just by itself, so that's how we write it. Union, and then we're starting up at 5 again, so we're going to go from 5, but this time we're going to include the 5 to infinity. Okay, now we're looking for where the function is less than 0. So I'm going to highlight all that. And all of this is less than 0, except where it's actually at 0. Right? If that's 0, then it's not less than 0. So we have two chunks here. We have this chunk, and we have this chunk again. So we're going to go from negative 3, not including negative 3 because we don't want to include the 0, to 2, not including 2 because we don't want to include it because it's 0 there, and then 2 to 5. Okay, so what it's saying, when I look at this, I'm thinking, oh, this must be all below the x-axis, but then it must touch it right here, right at 2, because I'm seeing we're going up to 2 but not including 2, and we're starting at 2 but not including 2. Okay, then lastly, we want it where it's less than or equal to. So now we're doing this whole thing including 2 because it's less than or equal to 2, so we're going to include this point here. So now we can just go from negative 3, include the 2, so just skip over it. We don't want to do brackets instead because that's just making it messy, to 5. Okay, so we're including that 2. So it's all below the x-axis and including right there. All right, so how are we going to do this without a graph? Well, you're going to create a sign chart. So here's how you do that. I've given you a function here, and I'm asking you for when it's greater than or equal to, less than or equal to. So there's a couple steps in this. The first step is we're going to determine what the real zeros are, and all these functions are the same. I'm just having you look for different things for each function. So we have a 0 at negative 3. I'm actually going to write them over here. So we have a 0 at negative 3. Okay, and so where else can we create a 0? Well, what would I have to put in here for there to be a 0 here? Well, if I put in a positive 1, that would be 2. If I put in a negative 1, well, negative 1 squared is positive 1. That would still be 2. So this isn't a 0 here. There's no way to make this one 0. So now here, what could I put in here to create a 0? Well, I can put in 4. 4 minus 4 is 0, and then 0 squared is 0. So I found my zeros. I have them at -3, and 4. Okay, next you're going to create a number line with the zeros placed in numerical order and spacing doesn't matter. Okay, so we don't need to make sure that there's the right number of spaces between -3 and -4. We just need to go ahead and create it, and I'm going to do that down here. So that -3 is on the left, +4 is here. And then I'm just kind of leaving even spacing between the three parts here, and you'll see why in a moment. I'm also going to write 0 above each of these to remind myself that this is where the graph touches the x-axis. Okay, next you're going to plug in x values on either side of these zeros and determine where the function is positive or negative. Okay, and that's one sentence for a whole lot of things that are going to happen down here. So when you go to do the for you to try, if you need to, I would just rewatch what I do here. But eventually you'll know what you're doing, and this will just be a hint to get you started. All right, so plug in x values on either side. So these are all the same, so I'm just going to look at this one right here. So I'm looking to see, well, if I were to plug in something smaller than -3, like for instance -4, I just want to figure out what the resulting sign would be for each of the factors. Okay, so for instance, in my brain here, I'm plugging in -4 and I do -4 plus 3 and I get a negative. Doesn't matter what my answer is. It doesn't matter what number you choose. You could choose -4, you could choose -10, whatever works for you. But if I plug in a negative that is smaller than -3, for this first one, I'm going to get a negative. Then for this second one, if I plug in a negative that's smaller than -3, like -4, squaring it's going to make it a positive. Adding 1's still going to be positive, so this is actually a positive. And then -4 minus 4, well, that's going to be a negative, but once I square it, it's going to be a positive. So I have a negative, and we're multiplying here, a negative times a positive equals a negative. Just like that. All right, between -3 and 4. Well, the x value 0 is between -3 and 4. And I'm not talking about the zeros as far as when it hits the x-axis, but the number 0 is between -3 and 4. I use that whenever possible because it makes things kind of easy. If I plug in 0 here, this one's just going to be positive. If I plug in 0 here and square it plus 1, it's going to be positive. And I plug in 0 here, this is going to be negative, but then I square that, and I'm going to end up with a positive. So a positive times a positive times a positive is going to give me a positive. Okay, one more time over here. I need a number bigger than 4, so 5 or 10 or whatever you want to use. 5 plus 3 is going to give me a positive. 5 squared plus 1 is going to give me a positive. 5 minus 4 would be a positive, and then I square it and it's still a positive. So all of these are positive. Okay, so in my brain now, you don't have to draw this graph over here every time you do it, but in my brain right now, I'm thinking, okay, well, there's something at -3, and there's something at 4, or 0, I should say, not something. It's negative down here, and then it's positive, and then it's positive again. Right? This is what's going on in my brain when I do this. So you can draw the graph, but we're trying to get to the point where we're just using the sign chart. So now I want to know, where is the function greater than 0? Well, that's where it is positive. So it's greater than 0 from -3 to 4, and we're not including -3 because it's not equal to. So -3 to 4, union. We're going to jump over this 4 here because that's where it's 0, and again, it's not including 0. So we're going to pick it up again at 4, and then to infinity. All right, where is it greater than or equal to 0? Well, now we are going to include that -3, and we are going to include the 4, so it's positive or equal to 0 the whole way from -3. And then second to last really. Now we want to know where it's less than, so it's where it's negative. So starting at -infinity to -3, but I'm not going to include -3. And then we don't have any more negatives the whole way. And then where is it less than or equal to? Okay, where it's less than or equal to, it's all before, so -infinity to -3. And I actually made a mistake here because we are going to include this 3 now. So be sure to fix this, but we have a bracket here because it's negative and less than and including 0. So it's all the negative and this negative 3. And then we have positive, 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 but here we have a 0. And if it's including 0, we have to include this 4. So we're going to show this as union and then a bracket just around the number 4. There you go. And then just to confirm that, here's the graph of this equation here. So we're looking for where it's greater than 0, negative 3, all the way. And when I sketched it earlier, I didn't draw this in because I didn't know that it was there, and that's fine. We really just care about where it's above the x-axis. So negative 3 to 4. Not including 4, and then up again. So pause and take a look at all of these and match it to the graph and see if that makes sense to you, that our answers here go with this graph here. Okay, now we're going to do the same thing with rational inequalities. There's just going to be a small difference, but a pretty important one. Okay, as before, we're going to determine the real zeros, but we're also now going to determine where the function is undefined. And in this case, it's going to be a VASI because these guys aren't going to cancel out here. So where do we have a 0? Well, we have a 0. If I were to solve 2x plus 1 equals 0, and I solve this little equation here, I get x equals negative 1/2. So negative 1/2 is a 0. And then down here, well, if I plug in a negative 3, that would make this a 0, and then 0 times this would be 0. So at negative 3, it's undefined. All of a sudden, I forgot how to spell undefined, but my brain started working again. All right, negative 3, undefined. And then here at 1, it would also be undefined. Now we're going to create a number line with the zeros and the undefined x values placed in numerical order. Okay, and then lastly, we're going to plug in x values on either side of these values, right? So we'll look at that in a second and determine where the function is positive or negative. So we're doing the same steps as the last one. It's just some weird things are going to happen because we're not always having a 0 when we go to find where it's greater than or equal to or greater than or less than or equal to. All right, so we got to put these in numerical order. I'm going to start down here with negative 3. I'm going to write above it that it's undefined, so I don't forget that. Then I'm going to go to negative 1/2. And I'm going to write above it that it is a 0. And then I'm going to go to 1 and mark that as undefined. Okay, so now I'm looking for values on either side. So negative 3, I just can pick a value over here. I'm going to go with negative 4. So if I plug in negative 4 on top, well, that's going to give me a negative. Negative 4 times 2 is negative 8 plus 1. So I get a negative on the top, and I'm going to draw just like a little rational function down here just with signs. And then on the bottom, if I plug in a negative 4, well, that's going to give me a negative here. And if I plug in a negative 4 here, that's going to give me a negative again. So I have a negative divided by a negative times a negative is a positive, and a negative divided by a positive is a negative. So make a note of that. Same thing here. We're just looking for a number between these two. Negative 1 works well for me. So negative 1, if I plug it in here, is going to give me a negative on top. If I plug in a negative 1 here, I'm going to get a positive for that factor. If I plug in a negative 1 here, I am going to get a negative for that factor. Combine these signs, and I get positive. Keep going. You might want to pause the video and see if you can come up with these yourself, but you need a value between 1/2 and 1. I like to use 0. Go ahead and pause, see if you can come up with them, and join me when you're ready. Okay, hopefully you've come up with some. So 0 on the top is going to give me a positive, 0 here is going to give me a positive, and 0 here is going to give me a negative. So positive, positive, negative. Hopefully after you've done this for a while, you start realizing, well, if I have an odd number of negatives, it equals a negative. If I have an even number of negatives, it equals a positive. And here I have an odd number, so this must be a negative again. Okay, you can always just do the math to figure it out, but that's also a pattern that hopefully some of you will start to observe. And then for this one, we should have ended up with a positive, positive, positive. So, positive. All right, we got to figure each of these out now. So where is it greater than or equal, or sorry, just greater than 0? Well, that's where all the intervals on which it is positive. So -3 to -1/2. -3 to -1/2. And then again at 1 to infinity. Okay, next we're going to see where it's greater than or equal to. And here's where things are going to get a little bit different than the last one, because if it's greater than or equal to, we're only including where we have zeros. Okay, so right here, it's undefined. So we're not going to include this -3. So we're still going to have a parentheses here at the -3. And it's positive, it's greater than, positive, all the way to -1/2. But this one's a 0. And we're saying we want to include the 0, greater than or equal to 0. So we have all of this, and we have this -1/2. So -1/2 with a bracket around it. And then over here, well, this again is not included. This is not a 0. We should have, there's an asymptote here, which we'll look at in just a moment. So we're going to start up at 1, but not included, and then we're going to go to infinity. Okay, less than. So less than, we're talking about -infinity to -3, not including it. And we're also talking about -1/2 to 1, not including that either. Now we're looking for less than or equal to, so we're still looking at these negative areas, but now we're negative up to -3. Do we include the -3? Well, we're not going to include it because it has to be 0, not undefined. So this first part is going to stay the same, -infinity to -3. And then this is a 0. So now we're going to include that -1/2, and we're going to go to 1, but we are not going to include this 1. Just like that. Okay, so you might be thinking, well, if I know how to graph this just by looking at the equation, why can't I use that instead of a sign chart? And you can, technically it's the same thing, but what's the nice thing about the sign chart is that it can then be applied to rational functions, because as you know, graphing the rational functions can be pretty tedious, and we don't need all that information. We just need to know when it's above or below the x-axis and when it touches the x-axis. So a sign chart's good for that. And then we can also solve inequalities like this using a sign chart, which is something that we may not know how to graph. Before I get into that, I did want to show you the graph for this one. All right, so we did this rational one. Now let's see what that graph looks like. So take the time to examine these two and see if these match up. But you can see that we do have an asymptote here at -3. There's 1, 2, 3. And we have an asymptote at 1. So that's why we're never including those values. But we can see that we have a 0 at -1/2. See if all these match up with this graph here. Okay, coming back to this, we can use a sign chart again. Okay, but this time we're also going to have to figure out the domain. Okay, so our step number 1 changes a little bit. Determine the real zeros and the domain of the function. But the rest of it's going to be the same. So if you, after you do this, want to write in some more steps, go ahead. But I just want you to make the connection that you can now apply this sign chart really to any kind of funky function that you can find if it's in factors like this, so parts that are being multiplied together. All right, so we know that there is a 0 at 3. So 0 at 3. And where else is there a 0? Well, if I plug in -1 here, there's a 0 there. Okay, but we have something else funky going on, because if you remember I talked about things that affect domain. There was even roots and rational functions when you have a 0 in the denominator. So there's something that cannot go in here, and that would be negative numbers. So we have to see what the domain is for this function. So we can have a -1. It's going to cause a 0. And then it's going to go to infinity. But we can't have anything less than -1. Because if we have a -2 in there, then we have a negative under our radical. All right, so rest of the steps are the same as before. We're just going to put this in. We just need to put these in. So I have a -1 here and a 3 here. And then how am I going to include this? Well, all this is instead of this being positive or negative, it's just undefined. There's nothing over here at all. This -1 is a 0, so we'll write that on there so we remember that. This 3 is a 0, and we don't have any undefined single points here, or asymptotes, I should say, single x values. We just have all of these x values that are less than -1. All right, so we're going to plug in some numbers. So I'm going to use 0 because that's between -1 and 3. If I plug in 0 here, I would get a negative value. If I were to plug in 0 here, I'd get a positive value. When I multiply those together, it is negative. Okay, something greater than 3, I'll do 5. When I plug in 5 here, I get a positive value. And when I plug in 5 here, I'm going to, of course, get a positive value because it's an even root. So here we have positive. Okay, for this one, we're not looking for all 4 different cases. We simply want to know, when is this function greater than or equal to 0? So where is it greater than or equal to 0? Well, that would be over here. This is positive, and our 0 is 3. But equal to 0, that means we also have to include this -1 here. So our answer, I'll put it over here. We have -1. Just that -1. And then we jump all the way over here to 3. We're going to include 3. And we're going to go to infinity. So that way we have all the parts that are both greater than and also equal to 0. Might as well take a look at that as well. Here we have a point that's on the x-axis is 0, then we're below, and then right here we are on the x-axis at 3, and then to infinity. Okay, I want you to use a sign chart for both of these and find out where the function is greater than 0 and write it in interval notation. Same with this one, find out where this function is less than or equal to 0 and write it in interval notation. All right, thanks for watching, and I'll see you in class.